Hi everyone, my name is Heng Ki Chuan. I'm a KKK student from UTEM. So today I'm going to present my FYP title, which is Quantitative Analysis of Deep Learning Based Smart Camera as Pedestrian Sensor. And my SV are PM Dr. Su Yu Guan and PM Dr. Lim Kim Chuan. There are three objectives to be achieved in this project. The first one is to collect the data with the required camera view angle for training and testing. While for the second one is to design a deep learning algorithm for the smart camera that having at least 90% of present detection recorded for vehicle and pedestrian. While for the final one is to evaluate the performance analysis using MFP, which is mean accurate precision, as a parameter to detect the accuracy for big, medium, and small objects throughout the dataset. The scope of work, here I show the choice I choose for model use, backbone, and the hardware. The pixel size is shown in the table for big, medium, and small image. Through this FYP, a smart camera that having present detection recorded at least 90% for vehicle and pedestrian can be designed and present. But the limitation due to this MCO phenomena, there are least pedestrian crossing the road and it's hard to find pedestrian. Besides that, the labeling job is very tiring because I'm doing it manually. Introduction of deep learning. Object detection is modeled as a classification problem where we take window of fixed size for input image at the possible location and fit these pages to a image classifier. It means I do the labeling job in Ubuntu. I boxes for the image. There are 7 classes to be detected, which are car, motorcycle, bus, and lorry, van, bicycle, and pedestrian. So there are so many input in this dataset, hence the CNN is chosen because this is one adapted for analyzing and identifying visual data such as digital image and photograph. Starting from the collecting data from the camera installed at the junction, using the AnyDesk to get videos, and I split the video into pieces of images per second. Then I do it with labeling using Ubuntu, using the label I made from the apps. So I need to draw the box pieces by pieces in each of the image. If the video consists of 60 seconds, then I need to draw a lot of cursors in one frame of the picture. So it's very tight again. Then after I finish all the data set, I upload to the Google Drive and then start with the Google Colab. Why I use MobileNet SSD? Because it is a lightweight deep learning architecture designed for mobile and embedded vision application. So it's very light and fast compared to the others. And the SSD take one single shot to detect multiple objects within image. So it can classify the image very fast and good. So this is why SSD being chosen compared to the others. And accuracy, so we choose SSD. For the MobileNet V3, which is the backbone I use in this training, you can find from the data. It shows that MobileNet V3 is 27% faster compared to the others older version, maintaining the similar MFP. This is the MFP I mentioned about. is a popular evaluation metric being used for object detection, for example for localization and classification. What is localization? Localization determines the location of an instant bounding box. This means the boxes in the Ubuntu I showed in the first slide. And classification tells you what it is. The MFP for big, medium, and small objects together with precision and recall will be analyzed for the CNN trend, the mean, average, precision. Score is calculated by taking the mean AP over all classes and overall IOU threshold depending on different detection challenges. But in here, I just use the sensor board to help me to show the MFP graph for the training model. Also, the present detection means help to count the very least number of pedestrians so that there would be any pedestrian that being not counted by detected by the AI camera. Is used to measure the reliability of the present detection dataset that fulfill the requirement which having equal or not more than two pedestrians inside the detection area and is collected and separated, and this dataset is used to train and the accuracy shows the reliability of this present detection. Application and commercialization potential. Why I come up with this idea, choose, why I choose this title. Why I choose this title? Because it has a lot of commercialization potential compared to the old method, which is the push button. This allows disabled pedestrians to cross the road safely, and it's very convenient. Don't need no more going to touch the push button under the very sun. And the next one is this replacement. It can use as a traffic signal controller to prioritize different category of user at different times. Also, it can be installed in a large-scale vehicle to see the angle that cannot see by the driver and detect the human surrounding. For example, the forklift, storehouse, and the school bus help to prevent the accident from occurring. Sustainability and environment friendly. It acts as an automated statistic collector for traffic junction. It can be used to improve the traffic signal timing. It is more durable compared to pedestrian push button. It costs less money to maintain and display. This is a news for Dhaka. How the zebra crossing is changed to wireless pedestrian detection technology, and it costs almost 12K. I think a smart camera would cost that much. This is the data set collected from the ad camera. Here is the Google Collect. This is the first step. I mod Google Drive, Google Collect. Here to install the Python 3 so that I can use the TensorFlow. This is the importing the library I use for the training process. Here shows the get the data set and open the folder to search the file as XML.
So this is my result for MMP and each of the readings.